Good afternoon, everyone. So as we promised yesterday and discussed also, we would be taking determinants today. Very excited for this session because determinants is a topic where, the question is always there in the exam, right? So any exam paper you take it out, you will find there is an a question on that. And one more important question about determinants: the same question can be asked for objective and theory also. So we will see that one as well. So yes, meanwhile you can register. I hope on the screen you are able to see our website, my tutors online, and yes, and you can register the YouTube channel also, my tutors online, and there is a website www.mytutorsonline.org. You can get instant tutoring for the same. So if you want to have a live class with one of our coaches, he can guide you for your doubts and everything. There is a course also starting, which it is already started. We are already working with students where we teach them as for the JEE mains and advanced. So if you want to work with our coaches and learn maths or physics or chemistry, biology, any subject, any curriculum it is, irrespective of curriculum, you can just get your instant tutoring. You can get even demo class first if you have that eagerness to join our platform. So we hope that we bring the highest and the very simplest, actually highest and simplest value to you in terms of education. So yeah, I hope I hope I am audible and visible as well. I'll just give me a minute. I am just going to share my screen to you so that we can start the topic. Yeah. So I hope the screen is visible to you. And yeah, this is our one of classes which we were holding for. Yes, yeah. Good. So let's solve determinants. So the only difference between matrices, which we saw yesterday, you must have seen the video afterwards if you are not online, is that determinants is a number, matrices is arrangement. Determinant is a number. We will see how we calculate that. Before that, we have seen how the matrices are, then what are the types of matrices, and we will see. But determinants are only valid for square matrices. So that is one of the issue. And yesterday I was speaking about square matrix, where I also gave the example of chessboard, where we have used square matrix at some or other point of time in our life. And square matrix is something which has lot many properties and used for inverse and everything. Only the square matrix we are going to see here, whose determinants can be solved. So if it is 2 by 2, let's say, I'm just giving an example, 1 2 4 7, something like that, then multiply the diagonal elements 1 into 7 and minus remaining elements 1 into 7, 4 into 2. That's how it is. So as I said, the determinant is always going to be a number. We need to understand that there would be calculation of addition and subtraction and multiplication involved. Obviously it is a number. So the value of the determinant is calculated by multiplying the certain number of numbers, by leaving certain number of rows and everything like that. We will see that from the, this is very easy for 2 by 2. For 3 by 3, let's see how it goes. I'm just taking a random example. Now let's see how we can solve. So the sign convention, that is, this is considered plus, this is considered minus, and this is considered plus. This will go on, you know, diagonal elements minus the other two elements, multiplication of other two elements. That will happen for every number, but I am just telling in general the sign convention is plus, minus, and plus. So plus 1, plus 1. What is the next convention? One is plus 1. One is the addition that is happened. Second is convention is whatever number you are calculating for. Whatever the number you are calculating for, you have to leave the first row and first column, because we are calculating for A11. What is A11 in this case? It is 1. So A11, what is 1 indicate? What this 1 indicates? A row. This indicates column. So first row and first column. The digit here or the number here is 1. So plus 1 into. We have to cancel out this, basically this and this imaginary. 0 into 2. So okay, let me write this first, which will be minus. Convention is minus 4. Forget the column and the row. So forget this and forget this. So 2, 3, 1, 2. 2, 3, 1, 2. Okay, very good. Sign convention as again plus. What is the number? Minus 3. Very good. Next. What is the minus 3? It is here. So forget this and this. 2, 3, 0, minus 1. 2, 3, 0, minus 1. Okay, plus 1. Multiply the diagonal minus the remaining. Same thing we are going to do. 0 into 2 minus 1 into minus 1. Minus 4 into 2 into 2. Minus 1 into 3. Minus 3. 2 into minus 1. Minus 3 into 0. So I know that the multiplication is easy, but the sign convention and which numbers to take is important. Multiplication is not going to be issue for you, but yes, plus 1. So it will be 1 only, 0. This will be plus 1. Minus 4 into 4 minus 3. Minus 3 into minus 2. Okay, that is anyways going to be 0, 1. Plus 4 plus. So the determinant, as we promised, it is going to be a number, and I think this is minus 4, yes, and plus 6. So yeah, 3. So the number, so the determinant is going to be a number for us, and here the number is 3. Two things you have to remember here while calculating the determinant of any matrix. One is sign convention, plus, minus, and plus. Second thing is whichever number you are considering for, whichever A11 or A12 or A1, whichever you are considering for, you need to forget that row and that column. So row and column, and rest of the number you write it and then calculate it. So initially when you are solving the problem, you can use this step. But as and when you are practiced 2-3 examples and you know that okay, this is how it works, you can skip this step. Even in exam there is no problem, but it's always going to be used when you are going to solve the example. Now there is something called as cofactor also. So this we know that there is a okay, before that cofactor, let's learn minor. Actually cofactor comes with sign equation. Minor. What is minor? Minor is the determinant of a number. It's a determinant again. Is a number where you are again forgetting the row and column in which it is involved or present in the particular matrix. So I will just take a very simple example: 1, 2, 3, 4. So here minor of A11. So minor of A11 is indicated by M11. Minor of A11 is indicated by M11. So M11 is going to be exclude this, remains 4. Sign convention is as it is, plus. So don't have to worry for minor. For determinant, you have to worry. For minor, there is no sign convention. M12, first, second. So for 3 we are solving. So A12, that is 3. For 3 we are solving. So we will forget this and this. So whatever is remaining, 2. M21, what is M21? 2. So forget this and this, 3. M22, 4. So forget this and this, 1. These are the minors. So similarly for, I will just parallelly take 3 by 3 also. This square matrix was of the order 2. Let us take the matrix B. Let us name it as A. And this matrix as B, and let's take this as 3 by 3. 1, 0, minus 1, 2, minus 3, 1, minus 2, 4. Let's keep it 0. Yeah. So this is 3 by 3 matrix, and we want to calculate the minors. Calculate minors. So the question is very simple. B is equal to 1, 2, minus 2, 0, minus 3, 4, 1, minus 1, 1, 0, minus. In determinants, only first 3 elements, we have to understand the how we have to calculate. In what happens with each element, we have to calculate. This will be why we are learning minors and cofactors. You will understand, because it is needed for adjoint. And why the adjoint is needed? For inverse. If you know that for inverse of the matrix, there is a formula where there is a determinant, and where there is an adjoint. So determinant we have learned. So inverse, there ultimate purpose of our solving the determinant is this. What is that purpose? So that I can calculate the inverse of any matrix, or I can use the formula of, use the basic concepts of determinants and find out the inverse. So there are issue with internet. I'm sorry for that. Yeah, so I hope now I am visible and audible. So we were studying the first step, that is minors. So for what? For inverse, a inverse, for that determinant part is done. Let's see minors. Minors, I am directly going to write m11. Okay, m11. So it is for 1. So you are going to forget this and this. So minus 3140. Minus 3140. Remember, I am not writing that symbol, square bracket symbol. No, it is going to be determinant. This is a number. Number we are not writing in square bracket. Only square bracket is used for matrix. Yes. So minus 3 into 0, minus 1 into 4. So this is minus 4. M12 similarly. 1 2, that is for 2. So forget this one and this one. 0 minus 1 4 0. M13. So first row will get completed now. First row and forget this. First row and third column. First row, third column. So 0 minus 1 minus 3 1. 0 1 minus of minus 1 into minus 3. So it is going to be minus 3. First row is completed. First row is completed. I hope it is clear. Let us go for M21. Second row and first column. Second row and first column. 2 1 minus 2 0. 2 1 minus 2 0. This is going to be 2 into 0 minus of 1 into minus 2. It is going to be 2. M22. Forget second row, second column. Second row, second column. 1 minus 1 minus 2 0. 1 into 0 minus 1 into minus 2. So this is going to be minus 2. M23. So M23, what is going to be second row, third column? So we are calculating basically for 4. 1 minus 1, 2, 1. 1 into 1 minus 1 into 2. So 2. Let us calculate for third. So M31. Third row, first column. Third row, first column. 2 minus 3. And I think this is 2 minus 2. 2 minus 2, 4. Minus 2, 4. So this is going to be 2 into 4 minus 2 into minus 3. 6. So this is going to be minus 6 and 8. So it is going to be again 2. M32 and M33. Let's calculate that. Yeah. So 32 means third 2 4. 1 0 minus 2 4. Third row, third column. 1 0 2 minus 3. So 1 into 4 minus 0 into minus 2. It is going to be 4. 1 into minus 3 minus 0 into 2. So again it is going to... Now, yes. We got all the minors. What is cofactor? What is cofactor? I am simultaneously teaching you what is cofactor. Cofactor is minus 1 to the power of m plus 1 or I plus j, you can say. M into n is the power, the order of matrix, but I is the number of row, ith row and jth row we call it. So I indicates now row and j indicates, so 1 plus 1 into minus 4. Yeah. So minus 1 raised to square is 1. 1 into minus 4 is minus. Minus 1 raised to 1 plus 2 into 4. First row and second column. Concentrate here. So it is minus 1 into 4, minus 4. Minus 1 raised to 1 plus 3, minus 3. So this is minus 3. Minus 1 raised to 2 plus 1 into 2. I am taking these values only, okay? Just I am applying with minus 1 raised to power I plus j. So I is number of row and j. So minus 2. Minus 1 raised to 2 plus 2 into minus 2 obviously. That is going to be again minus 2. M23, that is minus 1 raised to 2 plus 3 into 2. It is going to be minus 2. Again, minus 1 raised to 3 plus 1 into 2. It is same. Minus 1 raised to 3 plus 2 into 4. It is going to be minus 4. Minus 1 raised to 3 plus 3. Third row, third column into minus 3. It is going to be minus 3. This is what, I'm sorry. These are our cofactors. Whatever you see on the right side are all cofactors and indicated by C, and this is nothing but C11, C12, C1, C21, C22, C23, C31, C32, and C33. And we can write this as we got minus 4, minus 4, minus 3, minus 2, minus 2, minus 2, 2, minus 4, minus 3. That is how the cofactor we have got. Now what we do with cofactor, as I said, from minor you get cofactors, from cofactors you get adjoint, and from adjoint you get A inverse. That is what the stages I told. Minors is done, cofactors is done. What is adjoint? Adjoint of A is nothing but C transpose, the transpose of matrix obtained by cofactors. C transpose means minus 4, minus 4, minus 3, minus 2, minus 2, minus 2, 2, minus 4, minus 3 transpose. What is a transpose? Rows get converted into columns, columns get, that is what, vice versa. So minus 4, minus 4, minus 3, minus 2, minus 2, minus 2, 2, minus 4, minus 3. So it is what we have got. This you are saying is nothing but a cofactor. I will repeat the stages. You need to calculate determinant first. Second step, okay, step 1, step 2, you calculate the minors. Know the determinant, how to calculate minus 1 raised to I plus j. You multiply the minors, you get cofactors, you transpose the cofactors. Very good. That is where the formula for formula minus 4 minus 2 into 0 plus 4 minus 2 into minus 3. Okay, so minus 4 minus 8 So what I am going to do, also, yes, so you can do that always. So you got the inverse. So I am going to repeat the stages. Is so that I can formula to calculate the inverse of matrix. Also, I am going to quickly cover one application of determinants. So, you know, any topic we learn, you should also know that there is application of derivatives, application of differential equation, application of integration, application of definite integrals. Similarly, there is application of determinants also. That is area of triangle. I am quickly going to take you to this. Suppose there is a triangle. Criteria is you should know all three quadrants. I mean the coordinates: x1, y1, b, x2, y2, c, x3, y3, x3, y3. So the area will be given as 1 by 2, x1, y1, 1, x2, y2, 1, x3, y3, 1. It doesn't matter how you write. If you write x1 y1 and here you write x1 y1, if you write here x3 y3, it doesn't matter, area does not change. Only thing you have to make sure that area should always be positive. Area can be only positive, area cannot be negative. Area can be directionally negative. What do I mean by that? If this is a triangle of area with 28 square units, yeah, it may happen that you will have a triangle here which can have a minus 28 according to the calculation of determinants. Yes, by directionally it can be negative, but the area, the quantity itself cannot be negative. So in both the cases we are going to write the answer as 28 only. So please remember that in area of triangle it is positive always. It can be directional negative, of course. Here three criteria is if you know the three coordinates of triangle, and once you know the three coordinates, then it's easy to calculate the area of triangle. What is the area of triangle? Half determinant of x1 y1 1, x2 y2 1, x3 y3 1. That is how you have to calculate the area. So we saw how to calculate the determinant, we saw how to calculate minor, then cofactor, then adjoint, and then eventually inverse. Application also we saw, that is area of triangle. That is one application. Second application I'll quickly tell is to find out if the points are collinear. How do you find out that? Very simple. Now you see let me tell you that, let's say A, B, C, you can clearly say they are they are in straight line, they are collinear points, which means what? Area will be obtained by them will be 0, right? So the same formula of x1 y1 1, x2 y2 1, x3 y3 1, just take it 0. If it comes 0, which means area formed by 3 points, if it comes 0, what it means? These are collinear points. As simple as that, right? These are collinear points. And if does not come to 0, that means it forms a triangle and it will have a positive area, as we take in the previous application. So the first is area of triangle, you will anyways get it. If area of triangle comes 0, then you can safely say that they are collinear points. Now there is another method also. They will say k to k, k minus 3, minus 3k plus 1, 4k. These 3 points are collinear. Find out the value of k. What you have to do? You have to take these points, then you need not take this half. Just take it, just put these 3 points here, equate them to 0 and calculate the value of k. Did solve the determinant as we have been solving throughout. Actually this determinant is even more easy to solve, because find out the determinant, equate it to 0, find out the value of k. So 3 types of problems will be asked. One will be application. In applications, find out the area of the triangle when the three coordinates will be given. Find out if the points are collinear. That will be the second application. Three, they will give that points are collinear. So ultimately the right side becomes 0. Yes, but they will not give the points directly. They will give some points in variable like constant like k. They will give like that. So three types of problems in application, and you understood why we studied determinants also. So it was good talking to you, and I hope the determinant chapter is clear to you. We saw the matrices. We also saw determinant. So any question you have out of these two, I have the sample questions also available. And if you come, I mean, if you will be there on the platform, you will be able to see the so yes, it was good having good talking to you. I hope it is clear. The topic is clear to you, and please subscribe to our channel. And yes, so you can see the website here, mytutorsonline.org. You can get instant tutor. I mean, instant tutoring on that. You can get live classes on that. For physics